Okay, welcome everybody. Thanks for joining us here in the room. And thanks to everybody that we have on the line with us in Zoom as well. My name is Patty Thiele. I am very privileged to be here today on behalf of Thomas Dalbert to represent the Friends of the Kauaʻi Wildlife Refuges. I am on its board of directors. I'm the vice president on the board of the directors. For those that don't know what the Kauaʻi Wildlife Refuges is, we are a nonprofit organization that supports the mission. Sorry, that supports the three beautiful national wildlife refuges that we have here on our island. Most people are familiar with Kilauea Point. That is because that is open to visitors, and so a lot of people are able to frequent that location, which is established to protect our endangered seabirds. But we also have Āholehole and ʻŌhiʻa National Wildlife Refuges, which are close to the public, but protect our endangered wetland birds. So it's a safe space for them to live here on the islands. The refuges, Āholehole and ʻŌhiʻa, have been around for about 50 years. The Friends group has been around for 41 years. So we're a well-established organization. And we provide resources through the generosity of all of the members of the community that we have to support the work that the U.S. Fish and Wildlife Service does. So it's a delight to be able to be here today, to be able to bring conservation voices into the room from around the island to share the great work that's being done. And we do this on a monthly basis as part of the partnership with the Princeville at Āholehole Community Association and the Friends of Kauaʻi Wildlife Refuges. So appreciate everybody coming here today. A couple housekeeping items. If you are in the room, just be cognizant of the fact that we are recording this. And so do keep your background noise minimal. For folks that are joining us through Zoom, please leave your camera off and your sound on mute so that we don't get background noise onto the presentation. If those on Zoom want to ask questions, give feedback, have comments, feel free to do that in the chat window within Zoom, and we'll then bring that information into the room so you can participate along with us throughout the presentation. If those in the room are not a current member receiving the newsletter from the Friends of Kauaʻi Wildlife Refuges, we have a sign-up sheet in the back of the room that you're welcome to provide our email letter or your email, and you'll get great newsletters with a lot of good content on what is happening related to our mission, as well as different wildlife throughout the year. And then most importantly, the next Princeville Moʻolelo will be in about 4 weeks from now on Tuesday, July 16th. And we will be having Brendan and Zico from Limahuli Gardens coming to talk about the propagation of and the care of Hawaiian plants. So I hope everybody will be able to join us then. But before we get to next month, today we get to hear about a lot of great information. Let me introduce our two presenters that we have. So we have Kim Rogers. She and her husband moved to Kauai for about a year. That was the plan back in 1999. And they're still here. She never left. So she has worked as a freelance journalist and as a photographer covering conservation science efforts across the state, as well as in various outreach roles on Hawaii on behalf of Hawaii's native wildlife. Kim says the thing that makes Hawaii stand out is its biodiversity of flora and fauna and the endemic species found nowhere else in the world. The native plants and animals, quote, hold the culture and stories of the place. In her capacity at KISC, she directs her energies towards helping save the state's endemic tree, the ʻōhiʻa, from the threat known as rapid ʻōhiʻa disease or rapid ʻōhiʻa death. And then our second presenter is Haylin Chock. Haylin was born and raised on Kauai. Her love for the land, the community, and the preservation of natural spaces pushed her to pursue a Bachelor's of Science from the University of Hawaii at West Oahu, where she graduated with her BAS focusing on sustainable community food systems. Since moving home to Kauai, she has worked with various nonprofits on Kauai, such as Malama Kauai, Limahuli Garden Preserve, and Malama Huliia. In her capacity at KISC, she engages with our community to demonstrate the destructive impacts invasive species have on our island way of life and inspire ways to prevent the introduction and spread of invasive species, as well as to enhance invasive species management and support. So welcome to both of our presenters, and we're going to turn it over first to Kim.
There we go. I think the mic is working. There. Okay. I'm going to try and get that off of there. So hang tight. Oh, it's not going to let me do that. Do you guys see that on the screen? Whoops. I'm trying to get the little thing that says this meeting is being recorded off.
I don't see it right now. I don't see
I know, right? Weird. Let's try this. Oh, now I got that. Okay. Let's try play from start. Now we're working. Yay, technology. Thanks everybody for joining us here today. Like Patty shared, I'm Kim Rogers with Kauaʻi Invasive Species Committee, and I'm working basically to save ʻōhiʻa, which is our state endemic tree, the most abundant native tree in our forest. Anybody here familiar with ʻōhiʻa lehua? Fabulous. Anybody have ʻōhiʻa growing in their yards? Okay. FYI, for those of you who do not, we oftentimes give away ʻōhiʻa. So if you sign up for our newsletter, you'll get updates on the next time we are giving away ʻōhiʻa because it will grow here. And in fact, the closest ʻōhiʻa to us right this very minute, there's more than one. There's young ʻōhiʻa that were planted along the trail over here. There's also a beautiful ʻōhiʻa behind the wooden fence structure across the street at the entrance to the library. So it is a very healthy, or it was, I haven't been there since they've been doing their construction, but right as you walk into the front doors on the left, there's ʻōhiʻa there and it's usually blooming. But you might be wondering, like I've heard other people say to me, why are you here talking about a tree? I mean, it's just a tree, right? So I'm gonna be sharing with you tonight that it's not just a tree. There's many reasons why we want to talk about it, why we protect it. But to give you an idea, in case those of you who are not familiar with ʻōhiʻa, the tree that I'm talking about, I've got just a couple quick photos. Here's one that was taken to kind of illustrate that this is one of our tallest trees in the forest. It is known as a canopy tree. And it is very abundant in the native forest, as you can see here. Those are pretty much all ʻōhiʻa that you're seeing in that photo. But they provide home to a whole host of flora and fauna. And that whole ʻōhiʻa native forest is super important to our watershed, which we're going to talk about in a minute. And in fact, I have a series of 4 videos that I'm going to play. They're each about 90 seconds long that kind of tell the story briefly about this particular tree. And I'm going to start with this first one, and that is growth of a forest and ʻōhiʻa's role in starting our native forests. So we're going to hope that the video and audio all works fabulously. It's not connecting to Bluetooth. So, oh, right. We will give this another go.
After a fresh novel, ʻōhiʻa's Florida, human eyelash, find their way into practicing ardent love, becoming one of the first plants to take root, thus starting a new ecosystem a biodiverse forest with tall canopy trees, understory plants, ground cover, ferns, and mosses. This multi-story forest pulls moisture from the bog and catches rain as it falls, allowing it to seep into underground aquifers, source of our drinking water. Forest vegetation also helps clean the air we breathe, and its leaf litter and complex root system hold soil in place, helping prevent erosion and runoff, ensuring a healthy ocean reef for fishing, surfing, and swimming.
Anybody recognize the voice? Oh, I knew this crowd would up here in Princeville. Yes, Sandy volunteered her talent, her audio talent for this whole series of videos. So you'll hear her some more. We miss her, don't we? Yeah. Just to quickly recap, so ʻōhiʻa is an endemic tree in Hawaii, endemic meaning found here in Hawaii and nowhere else in the world. We think its ancestor possibly comes from Aotearoa, which is known as the pohuta kaua. Also has a really tiny seed, much like our ʻōhiʻa, probably floated in the wind, somehow got up here, maybe hitched a ride on a bird, and took root and started growing and created, you know, there's just an abundance of trees. And primarily because it's a super adaptable tree. You can pretty much put it anywhere, any elevation on this island, and north, south, east, and west, and it will grow. That's not to say she can't be a little picky and finicky, but she has the capability and proven ability to grow on all parts of the island. And unfortunately here on Kauaʻi, you know, with the development and with you know, big ag, if you will, a lot of our ʻōhiʻa was lost at our lower elevations in recent years. But it is a keystone species, meaning a whole lot of other plants and animals rely on it for life, basically. And has the potential to grow up to 100 feet. As I mentioned earlier, we refer to it as a canopy tree. Also has the potential to live up to 1,000 years. So pretty much the mother tree. There happen to be 5 different species of ʻōhiʻa. We oftentimes refer to ʻōhiʻa as just ʻōhiʻa or ʻōhiʻa lehua, or some people refer to the tree as lehua. And you know, oftentimes in this idea that it's one species, but actually there's 5 different species of ʻōhiʻa, and within each species, there's a variety of varieties, right? So there's anywhere from 13 to 15 different taxonomic classifications of ʻōhiʻa. And this goes back to that adaptability. So over time, a seed floats into another microclimate, another area, experiences a different ecosystem, adapts to that ecosystem, maybe by having, you know, thicker leaves that are more drought resistant, or maybe more pubescent or furry leaves that collect moisture from the air, and then continue, their DNA continues to produce like varieties, if you will, of ʻōhiʻa. Also of note, this 5th variety or a 5th species that's mentioned up here, Metrosideros polymorpha, which is the binomial classification, the scientific classification of this species. In its 2nd word, polymorpha, tells us its superpower. So polymorpha, meaning many forms. ʻōhiʻa has the ability to grow, as I've mentioned a couple times already, up to 100 feet, canopy tree, as we see on the left. But you also see in this photo on the right that ʻōhiʻa, one variety of ʻōhiʻa, thrives in our bogs. And in Hawaii, and especially on Kauaʻi, we have high elevation bogs. What's interesting is the trees on the left you may be seeing might be several hundred years old. And you look at them and you kind of think that because they're nice and tall. But as well, these trees on the right, there's a couple that are blooming with the red flowers. Those are the bog species. They are not going to grow more than about knee high. So those species could very well be a couple hundred years old too. So it's that adaptability that has allowed ʻōhiʻa to become our most abundant native tree across the entire state of Hawaii. We also see not only in its stature, but in, if you look at the leaf itself, the leaf structure, the leaf margins, whether it's pubescent, furry, or glabrous, smooth, whether the edges curl under or they're flat, or the coloration. So we've got variegated ʻōhiʻa, we've got some ʻōhiʻa that are like this blue-green, we have other ʻōhiʻa that are lime green leaves. So it's this many forms, this adaptability is what has allowed ʻōhiʻa to thrive across Hawaii. We also see not only in the stature and in the leaf, but as well in the flower or lehua, a variety of color, right? We're probably most often familiar with the red lehua, but we also have orange. We also have yellow, which is a little more rare, known colloquially as mamo here in Hawaii, meaning yellow, and not pictured because it's super rare and some even don't believe it exists, but potentially a white lehua. And so if you ever come across a lehua anywhere across the state that has a white flower, you want to take photos and let me know as soon as possible. You'll get credit, but it would be a great find. So ʻōhiʻa creates this ecosystem. So as you saw in the video, as you've seen in some photos, collects water, fills our aquifers, the water that we have to drink out of our yetis every day, the water we bathe in, the water we cook with, the water that we water our gardens with, all thanks to ʻōhiʻa, quite frankly. ʻōhiʻa creates in the forest a sponge atmosphere. ʻōhiʻa is very welcoming, it's like very ohana concept, welcoming of other species, other plant species. You talk about other invasive trees, for example, like African tulip or albizia or strawberry guava. You go into a forest where they are present, and that's pretty much all you're going to find. You go into a forest where ʻōhiʻa is present, you're going to find canopy trees. They often partner with koa. You're going to find understory plants and trees. You're going to see ground cover. And you're going to see all kinds of mosses and lichen, ferns growing on ʻōhiʻa. It creates this beautiful biodiversity, and it also creates a sponge so that our forest absorbs water, allows it to slowly soak into our aquifers, provides water for us to drink, but as well holds soil and sediment in place so that after our big rains, we don't have that chocolate milk ring around the island. Unfortunately, we do have that, but what we want to see is we want to preserve our native forests so that we have a healthy ocean ecosystem as well. Healthy ocean means we have a healthy forest. Healthy forest means we have a healthy ocean. So those two are integrally connected. The next video we're going to play is a little bit more about the ʻōhiʻa as the tree of life and all of the other life forms that rely on ʻōhiʻa.
A native ʻōhiʻa forest is more than just a collection of plants. It's home to birds found only in Hawaii, and native beetles, butterflies, damselflies, and tree snails, many endangered. Some of these species have rich moʻolelo stories connecting them to the people and places of Hawaii. Many co-evolved with the forest, creating symbiotic relationships with plants. Āholehole, Hawaii's native tree snails, eat mold growing on ʻōhiʻa leaves, cleaning them and providing greater surface area for photosynthesis, a process that generates oxygen for us to breathe. No exaggeration to say, almost everything found in our native forest relies on ʻōhiʻa for life.
Thank you, Sandy. So a lot of people, when we talk about ʻōhiʻa and this connection with other flora and fauna in the forest, immediately associate it with our native forest birds. And there is a strong connection. And you know, ʻōhiʻa provide nectar for these birds, but they also provide insects. There's a whole lot of insects that live on ʻōhiʻa, provide a food source for our native birds. ʻōhiʻa provide nesting material for our native birds, as well as nesting habitat. Most of our, in fact, most of our endangered forest birds rely on ʻōhiʻa almost exclusively. So that if we lose ʻōhiʻa, we potentially will lose our forest birds as well. But I do like to always take a moment and recognize our forest birds and state their names, because we are losing, and I'm sure you've all heard this before, and I'm sure our friends at Kauaʻi Forest Bird Recovery Project have been here to speak. We are losing our forest birds. And by losing, I mean they're going extinct. And it's sad and it's dreadful and it's on our watch. But I always want to share their names. So this is the ʻAkikiki. And this is the ʻAkikiki. And this is the cutest little lemon drop of a bird that you'll find in the forest, and it's the ʻAniani owl. And sadly, their numbers are plummeting this year. This is the apapane, which actually is doing a little bit better, and it is one of the two that you could pretty easily still find up in the forest, apapane. This is the other red bird, EEV. Unfortunately, their numbers are plummeting. And this is the other bird, Kauaʻi Amakihi, which actually is showing potentially some resistance to avian malaria, and especially on other islands as well, but still a kind of a bird on the bubble. The Kauaʻi Alapaio is not a honey creeper, but this guy is also doing well, and one of the two that you could pretty comfortably find almost any day of the week up in Kauaʻi in the forest. They're a bit gregarious. We like to call them that, but it's pretty much only because they think we're going to kick up bugs. So they're smart, and they're like, oh, people, bugs, I'm going to follow you. And then this is the puaiohi, another endangered forest bird that actually doesn't rely on ʻōhiʻa exclusively. They nest in little pukas in cliff sides along streams. And they're not doing well, but the two that are of greatest concern right now is the ʻAkikiki and the ʻAkikiki. But beyond birds, I also want to share with you what I call our intriguing invertebrates, just to give you an idea of the other life forms that rely on ʻōhiʻa. You may have heard about kahuli, and in fact, they were mentioned in one of the earlier videos. This particular kahuli, I've seen on, well, it may not be this individual, but this species I've seen on 3 to 5 different occasions here recently, just this year. But get this, it likes to hang out on the underside of leaves. This particular species is about the size of a single flake of black pepper, right? So when I first looked at it, I didn't find it on my own. I had a biologist point it out to me. And I'm like, I still didn't believe her, naked eye looking at it, because literally it looks like a blemish on a leaf, because it looks flat. You don't even see the 3D. It was when I took out a hand lens that I saw the 3D nature of it, and I could see the whorls, and I'm like, oh my God, it truly is a snail. Adorable. This is another snail. So in the family that we refer to as kahuli. Unfortunately, on Kauaʻi, we know very little about our snails. So if you have young people, starting high school, college, this would be a cool avenue of study because it's sorely needed. We also have a whole host of different spiders that rely on our ʻōhiʻa forest. This one is known as the Kauaʻi spooky face spider. And the thing is, we only know of it on Kauaʻi at this point in time, but it potentially could be on other islands. It's just that people aren't out necessarily looking for them. So again, this is a huge opportunity for study. We like to think in our world today, we've discovered everything. Not true. There's a whole lot of species out there waiting for us to recognize them. In addition to kahuli and spiders, there's a whole bunch of insects, from bees and flies and damselflies and lacewings and grasshoppers and moths and butterflies. All of these exist in our native forest. Many of you are probably familiar with pulelehua, also called the kamehameha butterfly. Believe it or not, there's only 2 butterflies that we know of native to Hawaii, and there's hundreds of moth species. Sadly, we're losing moth species as well. But in addition, I just want to share some other great photos that a friend, photographer of ours, shares graciously with us, Graham Taliber. I'm just gonna click through these. Some of these, this is a weevil, this is a lacewing. I mean, he's out at night with macro lenses, taking these exquisite photographs. I know that kind of looks scary, but that's a caterpillar, turns into this. Here's another absolutely gorgeous moth. These are all native. And sometimes there is a new researcher who's been doing some work. And when he's on Kauaʻi next, his first name is Kyle. I can't think of his last name. Highly recommend if he gives a talk. I'm going to try and get him to give a talk for us to sit in on his presentations. His specialty is moths. But I kid you not, when these guys go out collecting, it's like every time they go out, they find a species that's not known to exist to science before. Honestly, yeah. So it's really cool. That's why I say we need more people studying these and learning about them. But they're hard to see and find. I mean, look at this one camouflaged in there. This, believe it or not, is an insect, and it's ʻōhiʻa gall, which tells you in its name that it definitely relies on ʻōhiʻa, has a strong relationship. This is a damsel bug, this is a damsel fly, and this is another spider. So I go back to the comment that I started with. But it's just a tree, right? But it's not. We lose ʻōhiʻa, we potentially lose a whole lot of other native species. So we don't want that to happen, right? Our next video is going to share with you some of the cultural connections that we have to ʻōhiʻa in Hawaii.
ʻōhiʻa has touched all parts of life in Hawaii. Strong wood is used for posts, flooring, once, hale, wa'a, and couple beams. Its flower, lehua, for medicinal purposes and woven into faith. ʻōhiʻa are celebrated hua, oli, and mele. ʻōhiʻa is our most abundant native tree. Without ʻōhiʻa, most of our native forests would be unrecognizable. Embodied in its very name, ʻōhiʻa is the essence of gathering and collecting, as in moisture from the air, as reflected in the saying, "Kaua noi lehua o waiʻaleʻale." The misty lehua rain of waiʻaleʻale.
So brief recap, basically at one time, and in some ways continues to this day, but certainly at one time, ʻōhiʻa pervaded literally all parts of life in Hawaii. Medicinal uses, as well as the wood, which is very strong and hard, used in building anything from canoes to homes. And there's a whole lot of song and chants and hula, all celebrating ʻōhiʻa. And that just tells you that, ʻōhiʻa was definitely literally a part of everyday life and sacred. It has associations with many of the different Hawaiian gods. Yeah, you just couldn't hardly move without bumping into ʻōhiʻa in some form or another. But unfortunately, there's a threat to ʻōhiʻa known as rapid ʻōhiʻa death. So this next video will explain what that is about.
A fungal disease known as rapid ʻōhiʻa is killing Hawaii's most abundant native trees. ʻōhiʻa are infected through open wounds, possibly due to peeling bark, torn roots, or broken branches. Microscopic fungal pathogens. Fungus grows inside the tree, preventing the flow of water. First external symptom, sudden browning of the leaf canopy. There's no known cure, and after a few months, the tree dies. Then ambrosia beetles, nature's decomposers, try to break down the tree. They burrow into the sapwood where the fungus grows, and spores into the environment with their excrement. Can go to another tree, or fall into the mud and be transported on shoes or cable tires from one part of the island to another. If these After each and every wounded ʻōhiʻa, the whole process begins anew. By practicing a few protocols, we can help stop the spread of rapid ʻōhiʻa death. Before and after entering the forest, brush mud off your shoes. Spray with isopropyl alcohol. Wash muddy vehicles. Avoid wounding ʻōhiʻa. Don't move ʻōhiʻa, dead or alive, around the island. Support the protection of remote forests. Most importantly, love ʻōhiʻa.
So that was like a bit of a complicated life cycle of the disease, condensed down into about 90 seconds. It can be a little complicated. It can be a little challenging. To recap, this disease targets ʻōhiʻa and ʻōhiʻa only at this point in time that we know of. It is a fungus. It grows on the inside of the tree. It's not something you see on the exterior of the tree, the leaf, the bark. And basically what it does is it acts like your kitchen sink on Thanksgiving Day. It clogs the waterway, the plumbing system of the tree, and water cannot move up or down. So it's oftentimes called a wilt disease. And the first visual symptom that we see of the tree that's been infected is the sudden browning of the leaf canopy. And unfortunately, once we see that, at this point in time, there's nothing we can do to save the tree. So as we've talked about, there are things that we can do to help stop the spread. But I want to back up and just share real quickly, this disease was first detected, started getting reports of dying ʻōhiʻa in about 2010 over on Hawaii Island. 2014, scientists were studying it, pathologists, plant pathologists, and they determined it was this fungus in the Ceratocystis family. Ceratocystis is a fungus found worldwide. It's very common, but there are 2 species of it here in Hawaii, found nowhere else in the world. And those are the 2 species that are killing ʻōhiʻa. Since then, and this is a little dated of a map, but you can see these are the detection sites where ʻōhiʻa has been known to die due to rapid ʻōhiʻa death. Pretty much the entire island. There's variations of it. Certain areas are more impacted than others. And in fact, this is one of the worst impacted areas. This photo was taken in Puna in 2005. Lush ʻōhiʻa forest, very healthy. And I'm going to warn you, the next photo is pretty drastic. 10 years later, 2015, this is what it looks like. So it's pretty devastating. We were quite surprised then in May of 2018 to have Kauaʻi be the second island to be detected to have ʻōhiʻa dying of rapid ʻōhiʻa death. So this is what our island looks like right now. So all of these dots represent areas where ʻōhiʻa have died of this disease. All total, the number of trees that we know of is about 500. Big Island, Hawaii Island, has over 1 million trees that have died of this disease. So relatively small numbers here at this point in time, although I will say there's likely a lot more than the 500. Some trees we're not able to get to sample. Some trees or samples that we take, if they're not a freshly dead tree, the molecular testing will come back inconclusive. But our most concerning areas on this map are the ones that are up here in the green. So these are the areas that are kokeʻe, the alakai, our most pristine biodiverse forests. And where our forest is working the hardest to provide us water and to provide home and food and safety to all of the flora and fauna that rely on ʻōhiʻa. So how is it moving around the island? Here's where it gets tricky. It can move in a multitude of ways. We can move it around the island in mud. Beetles, as you saw in the video, but beetles basically release the pathogen into the air, into the environment, and then wind can also move it. So the only way, though, for a tree to be infected is it has to have a wound. So you can have a dead ʻōhiʻa standing next to a beautiful, healthy ʻōhiʻa. And as long as that healthy ʻōhiʻa doesn't get wounded in some way, broken branch, pigs digging on the roots, that ʻōhiʻa will survive and be fine. And we've even got some science that's showing in some of these devastated areas on Hawaii Island where ʻōhiʻa seeds are falling to the ground, new ʻōhiʻa will start growing, which in a rod infested area, which is good news because that's telling us that the young regrowth is not taking the disease up through their roots. So that's a good sign. So that's how it moves around. Just to recap a couple of things, how do we protect ʻōhiʻa forests? Don't move ʻōhiʻa wood from one side of the island to the other, or soil at the base of the tree. And certainly, you know, honestly, not from island to island either is probably a good practice. And probably the number one, especially if you have ʻōhiʻa growing in your yard, is not to wound ʻōhiʻa. So another way to think about it too is we oftentimes think, well, pruning, well, I just won't prune it. But you also have to be careful if you're mowing around your tree or weed whacking around the base of it, not to mow over exposed roots and not to let the weed whacker string wound the base of the tree. ʻōhiʻa do not like mani-pedis. If that happens in ʻōhiʻa, she's like, I'm done. So don't wound ʻōhiʻa. And then practice good biosanitation before and after you go into the forest. Use a boot brush, get as much mud off, spray. Second step is to spray with isopropyl rubbing alcohol. That will actually kill the fungus. I think of this like going in our homes. We take our slippers off before we go inside the house. So the forest is our home as well. So let's, you know, keep our footwear clean. And then in addition to your footwear, trucks, vehicles, anything else that might get mud, even like walking sticks or even your backpack that you put down and it gets in mud. Just think of all the different ways you can reduce the spread of mud around the island. I like to say leave the mud where you found it, but if you're hiking in Kauaʻi in February, that's kind of hard to do. So you want to, you know, just remove as much as possible. And then the other thing, if you're, you know, thinking as I have always been, like, what can I do to help? Adopt an ʻōhiʻa. And by that, I mean, if you have a favorite hiking trail or a favorite place you go by that you see ʻōhiʻa, maybe it's the library, that you take note of it every time you go by it. You might even take a photo of it to where you've got like almost a time-lapse history of the health of the tree. And if you see it starting, the leaves starting to turn reddish brown, you let me know. And that's my email address. It's also on our website, KauaʻiISC.org. And if you would like, I send out a periodic newsletter. That's the QR code to my newsletter. You can sign up for that, get updates on what's happening with Rod on the island as well. I always have events where I'm trying to get more and more people into the forest with me. And next week, Friday, I'm taking a group up to the Arboretum in Wailua, and we do what's called forest journaling. It's basically, you don't have to be an artist, a scientist, or writer. We use our journals just to take in the place, get to know the place more, and feed our curiosity. The more we get to know places, especially here on Kauaʻi, the more intimate we become, the more we care. And you know, it just, again, continues to feed our curiosity. So it's a way to learn. And that's me. Anybody? Quick question? Yeah. So I'll repeat the question for those watching on Zoom. If you identify a tree and it's diseased with this fungus, is there anything you can do? At this point in time, no. But what we do practice is we want to not have trees around it die. So we try to make sure we're not spreading it. And so what that might mean, what that might look like in the forest is we might put a fence around this tree to prevent pigs from getting in, picking up the fungal pathogen, and then going to a nearby tree, digging at roots and infecting that tree. We might cut the tree down and then wrap it in a tarp or let ʻōhiʻa fern wrap it naturally so that we get that tree out of the wind column. so that the wind is not blowing the fungal pathogen, to a neighboring tree or the next valley. So there's different things, and there's one additional thing that is really showing positive. It hasn't been final approved yet. Early science out of Hawaii Island. It's basically a beetle repellent. So if we can keep the beetles out of a tree, then the tree is not releasing the pathogen into the air. So the beetle repellent is used with other diseases elsewhere in the world. It's a organic compound, and it's a pheromone. And it's basically like putting the shingle up on the hotel that says no vacancy. So the beetles wants to come in. Beetles, when they smell something that's dead and dying, our dead and dying trees put out a scent. The beetles are like, oh, good, I need to come in and do my job as a decomposer. They're just doing what they're supposed to do. But by putting this organic compound up on the tree, it's basically putting up the shingle, no vacancy, go somewhere else. And so the idea is that it will defer or deter beetles from burrowing into the tree and releasing the pathogen. So that won't work in a forest-wide setting. If you have a forest that's heavily impacted with rod, the compound has to be applied to each individual tree. It wears off, so you have to go back and do it again every few months. But if you have an area like Kauaʻi and the Āholehole, where we have only 1Z, 2Z tree detections, and you have a tree that pops up with rod, then we treat that one, right? So there's things happening. You may not be able to save that individual tree, but the idea is to stop it from spreading to other nearby trees. Yeah. There's a lot of great science being done. It's a great project to work on because management, outreach, and science is happening concurrently and sharing with each other. I have a meeting this Thursday with the entire working group, which, some projects, it's like science working in its own silo, management in its own, and outreach in its own. So yeah, I'm gonna wrap that. Oh, sorry, quick question. Oh, yeah, no, yeah. So the good question. The question is, once the fungus kills the tree dies, how long does the fungus continue to live in the tree? Good question, because a lot of people just assume, well, the tree is dead, the fungus probably just dies. No. So the viability of the fungus continues for, we don't know exactly how long, because we've only been testing it for X number of years. But at this point in time, it's probably 5 or 6 years that we're up to. But over that time, the viability reduces, but there's still some viable fungal pathogens in the tree. So again, that's why we say even if the tree is dead, don't cut it up and, take it across town, and burn it there or something, because you're moving potentially live fungal pathogens. Yeah. I'm sorry, how does the fungus replicate? Like fungi replicate? You mean it colonizes within the tree, so it's just growing? And I hope I'm interpreting the question correctly. Yes, I'm interpreting the question to mean, how does the fungus itself replicate in the tree? And it's just growing like a plant grows, right? It's just growing. But if it means replicates from one tree to the next, that's a different process. Yeah. Okay, I think I need to stop sharing, or I need to go to Haylin's presentation, which is, oh, no, I won't present. And you need to come over here.
Oh, my mic.
And your podium's over here.
I don't want to. Is it on? Hello, testing.
I can give you this one.
Yeah. Testing. Can you hear me? Zoom audience out in the interwebs. Can we get a thumbs up? Okay, great. Okay, am I good to go? Okay. Aloha kako. My name is Haylin Chock. I'm the outreach specialist for Kauaʻi Invasive Species Committee. I love working with Kim because our presentations always work really well together. And Kim gets to talk about all the really cool, fun discoveries of native species we have, but a really huge part of conservation that is often the not glamorous part of conservation, which is invasive species impacting our environment. To be honest, it's really depressing, but it's the reality that we live in, and the reason why that we still do what we do in all organizations is to combat these species, because as much as we want to focus on all the beautiful native species we have, which is super important, a huge problem that we have across the board is invasive species. It affects not only our native species in the forest, but as well as the ocean, how we go about our daily lives, our agriculture, our entire economy also can be impacted by invasive species. So tonight, I will be talking to you all about a general overview of how invasive species impact our environment, as well as covering some of our target species that we have at KISC. Perfect. So what is KISC? KISC is a grant-funded project under the University of Hawaii at Manoa, and we are under Pacific Cooperative Studies Unit. So we serve as like a gap-filling organization. Amongst my family, everyone says, she works for the state, she works for UH, she works for these things, so nobody can really quite place us, and that's kind of the point. We are a gap-filling organization. We focus on early detection and rapid response of invasive species. So typically, if you get a mongoose call, we are the first people on the scene. In a lot of ways for invasive species, we're the first responders. So our mission here at Kauaʻi Invasive Species Committee is to prevent species from becoming established on the island and become widespread on Kauaʻi that have the potential to have a big impact. So we focus on early detection. This includes our botanists going out into the field and looking for new threats that we have on our radar, a lot of early detection surveys, trying to be the first ones to find it. Or if we get a report, we're going to be the first ones to go out and inspect it and see where it is, and then figure out a plan of how we're going to control it. So invasive species is, like I said, it's a across the board problem. So typically it's not just KISC focusing on invasive species, but in all of these different organizations, we have invasive species present. So in some form of their organization, they also have invasive species on the radar. So our job is to work within and with these partners, because at KISC we have about 10 people, give or take, and you know, that's understaffed still. So even if we are fully staffed, we have maybe a field team of about 6 or 7 at any given time for the entire island. So give you that scope and that idea of how much we really have to cover. So in order to have these partnerships, it really gives us boots on the ground, but also eyes out. So the community is a big part of how we're able to get reports and to have more eyes than just our 6 people. And it's a huge part. So we work with organizations like DLNR, Hawaii Department of Agriculture, CGAPS, DOFA, and under the Hawaii Invasive Species Council. So here is another diagram about how the Invasive Species Council works. So it's kind of like a blanket where we all kind of communicate together. That's where threats that are statewide, like coconut rhinoceros beetle, we're able to connect with other islands because each island has their own invasive species committee. Not one ISC has the same list of target species because each island is presented with different challenges. For example, we don't have mongoose, which is great on us because KISC has done a really good job and have a really good relationship with our dock workers. So if we do have a stowaway, we're able to catch it. And that also protects our nene populations and our other native seabird populations. But on Oahu, I know that they're widespread. You can find a mongoose on any college campus. I know, because I've seen them. So under the Hawaii Invasive Species Council, that's where we kind of get blasted with SOS or new things to look out for, things that have gotten to Oahu and then may become a threat for Kauaʻi. And it's a statewide network. So it's not just KISC, it is all of the ISCs working together. So distinguishing between species, a lot of the time I get questions of, say pine trees are everywhere. Are they invasive? What about certain types of ornamentals? Are they invasive? Just because they're not native. So there's a miscommunication on what is considered native, what is considered invasive, and then what is considered ornamental and not a threat. So that is part of my presentation I'd like to focus on. So in order to get an understanding of the kind of landscape that we have in Hawaii, we need to look at the timeline of how things got here. Because at some point, this was just a rock in the middle of the ocean with nothing growing on it. And actually, the first thing to grow is ʻōhiʻa. And that created our foundation for which other plants are able to grow. So about 5 million years ago, Kauaʻi was formed by a geological hotspot. Nothing else was here. And then by natural ways, either makani, manu, or moana. And I always like, I know in school they teach 3 W's, wind, waves, and wings, but we're gonna Hawaiianize it. So makani, and if you're in the audience and you wanna participate, but for everybody here, I make the kids do the hand motions. So makani, this means wind, manu, the wings, and moana, the ocean. So all of our native species got here by the 3 M's. So our native species got here by their 3 M's, and some examples of that are things like the pulelehua, which is a type of pollinator, it's our kamehameha butterfly, mamaki, which is a native plant, iiwi and ʻōhiʻa working together, and also our kahuli. So there was about 300 ancestral species, about 1,200 native species at that time, and then it was 90% endemic here. After that, the first Polynesian settlers came, and of course, they brought things that they needed to survive. So around 1,400 years ago, we have kalo, ulu, la'i or tea leaf, and chickens were also brought, along with a host of other things. This is also where rats came. They hopped ship and they got their way over here. So that is one of the first invasive species that actually got to Hawaii. My formatting is a little off, but that's okay. So around 230, 231 years ago, there was the beginning of modern introductions that were intentionally brought to Kauaʻi for, agricultural purposes or economic purposes. So one of the intentional ones was cattle. Another one was goats for livestock. And an unintentional one was mosquitoes. But mosquitoes also may have hopped aboard with first European settlers as well and brought a host of diseases and created new vectors for that. So in the early 1900s, roaming cattle denuded forest, meaning they went through the forest, ate through a lot of things, and also a lot of forests were cut down to make room for cattle. This caused erosion, water supply failures on some islands, and millions of trees were planted actually in 1900 to 1940 to combat that. But all of those species were fast-growing invasive species, primarily planted for shading cattle. This includes albizia trees. So an introduction of invasive species started with the rat, of course. The mosquito is a huge one that we're dealing with now, but also plants. So we have blue sky vine here in the middle and strawberry guava. Also, to talk about the definition, an invasive species is not native and it can cause harm or will likely cause harm to the economy, environment, or human health. So today we have thousands of people, hundreds of thousands of people and things coming and going through Hawaii, whether it's through planes, through shipping cargo, through shipping all kinds of stuff through the mail. So by air or sea, there's constant inbound possibility for new invasive species to come. There's about 343 marine or brackish water species introduced every year. And Hawaii went from 0 to 40 land reptiles. It went from 0 to 6 amphibians, including the koki frog, which occasionally makes its way to Kauaʻi. I can answer some more questions about that later. There's about 8,000 plant species introduced and 20 or more new insects per year that are introduced. 54 species of ants are found in Hawaii, including little fire ant, and we do not have a native ant. So they're a pest. Every single one of them are a pest. So what are some characteristics of an invasive species? Why are we focusing on invasive species so much? They have the ability to grow rapidly, mainly because they can outcompete our native plants. I like to tell my students that I see that they're selfish. So invasive plants and invasive species are selfish versus native plants and species who like to share. If you may have noticed in Kim's presentation, whenever there's an ʻōhiʻa, there's always partner plants with it. They're always sharing, they're always together. But an invasive species is only caring about itself. It's trying to proliferate as much as it can. It has a high seed production. It has long seed viability, which is crazy. One of the things that we have is myconia, and myconia has seeds that are the size of a grain of sand that are viable for up to 20 years. Yes. So imagine you don't go hiking for 20 years, it happens to be on your boot, it germinates. Worst case scenario. Let's see, it also has a high dispersal ability, so it can get out there, such things like strawberry guava. It has habitat, it's a habitat and food generalist, so it can grow anywhere as well. So impacts of invasive species, they often threaten other plants, our native plants and resources. They compete for space, sunlight, nutrients, and some plants even do chemical competition against each other. So there's a change in the watershed and making it hard to recharge our water table and water cycle. Typically, if you see that brown water kind of out in the ocean, whenever there's a big rain, if we're looking out at Princeville right now, it's raining in the mountains, so it might be brown in a couple of days. That is a sign of an unhealthy watershed because there's a lot of runoff coming down and we don't have those native plants to hold our soil together. So here's a perfect example of why we don't want some invasive species. This is a photo of myconia. Myconia is found on Kauaʻi in an isolated area, and KISC has been working pretty much since the founding of KISC. It was one of the first species that was on our list to get rid of. At one point it was in Koke'e, but with the help of KRCP, we were able to get rid of it. So right now it's isolated in the Wailua area, and it has been for the last 22 years. This is a photo actually from Tahiti. So myconia, what it does is it grows in these monotypic stands, and they grow really tall. They can grow up to 50 feet. And the problem is they have leaves that are about 3 feet tall and 1 foot wide. So they can grow really big, and it creates an umbrella effect, which outshades everything else underneath it. So there's nothing else to hold the soil together. And on top of that, they have incredibly shallow roots. So if they're growing in a place like Tahiti with really steep cliffs, such as we have here, it's a perfect storm for a landslide, as we can see. And in Tahiti, myconia is responsible for 25% of the native species loss. Yeah. So KISC is working tirelessly every single week, surveying for myconia, finding new ways to look for it and to keep it contained in that area. So some impacts on the ecosystem include impacts on our native birds, such as mosquitoes, like we covered. So mosquitoes carry something called avian malaria, and with climate change, and they're able to live higher and higher at elevations, they're able to reach our rare and endangered birds, like EEV. Here's a photo of a strawberry guava dominated forest. As you can see, there isn't a lot of ferns and fauna growing underneath that. If you were to hike Sleeping Giant anywhere along that trail, there is nothing growing between the strawberry guava. Surprisingly, with my bachelor's in sustainable community food systems, it happens to be a lot of the species that I'm working on since I've started at KISC were agriculture species. Our agriculture is completely under threat right now. And I think I can't stress that enough for our community, is that invasive species, if they are let to go and proliferate as much as they want without our community eyes. Our agriculture system, our ability to feed ourselves with our local farmers is completely under threat right now. We are in trouble right now. I don't want to fearmonger anybody, but it's the truth. So here's some photos. We have banana bunchy top, which is a type of virus. There's something called fireweed that KISC actually eradicated, and that's a threat to livestock. It's toxic to livestock, but KISC did eradicate it. Here's a photo. You might not be able to see it, but if you're looking on your screen at the bottom of this coffee berry, this is called a coffee berry borer, and it's a type of ambrosia beetle that has threatened coffee on Kauaʻi, as well as Big Island. It's taken out a lot of the coffee on Big Island. And also there is mealybugs that are being farmed by little fire ants. So if you have little fire ant, you're double whammied with multiple different species. And then impacts to human health. So here's a sting of little fire ant on a baby's cheek. Little fire ant sting can sometimes last up to a week, and it can come back and forth. If you get stung once, it can burn for the first day, go away, come back, and it's like that for the whole week. There is a rare case where a child was stung in Oahu and they went into anaphylactic shock. So if they are sensitive to that, that is something to be aware of. And also the semi-slug. So the semi-slug is found on Big Island and Maui right now. This is a primary vector for the rat lungworm disease, which is a type of parasite. And I always share this story with my crowd that I'm with, that I had a personal friend during COVID. She was a microbiologist and she had her own lab. She was studying microbes in lo'i, actually, in lo'i kalo. She was in a coma for about a month. I think it was about a month. Nobody knew what it was. Everybody thought maybe it was COVID, maybe it was a combination of things. For an entire year, they didn't know what was going on with her. She lost mobility in her whole body. She lost a lot of cognitive ability. Come to find out, only through a spinal tap, that she had rat lungworm. She had eaten contaminated lettuce during a trip. And she had to go back to reading at a 3rd grade level and had to relearn how to walk. This is something I think that is completely overlooked, especially here on Kauaʻi. We have the ability to just eat from our gardens because we don't have this threat right now. But in the story of invasive species, it's a matter of time before we get a first detection. So I always want to share that story with you guys because it will impact you personally. So here's a photo of before and after, how invasive species can change how we view our own aina and how we can even interact with it. Here's a photo from 1980 of, I believe it's Rainbow Falls on Hawaii Island. As you can see the mountains in the background. It's a lot more open. There's a little bit of African tulip here. And by 2021, it's completely gone. You wouldn't know there's a mountain there. So it completely changes how you even see your own home. So how do they get here? Excellent question. So there's sometimes intentional importing where the horticulture industry does intentionally import things for their business, but then it's an accident where they bring in something that, you know, can spread. Part of our program is we have a plant pono partnership where we have certain nursery partners who voluntarily work with us, and they choose to not bring in lists of species that are known to be invasive. So we have a blacklist and we have a phase out list of species that are commonly sold in the horticulture industry that can become invasive. And by working with our partners, they choose not to carry those. However, not everybody is a partner. So to offer our audience that if you are planning to plant things in your yard, work with our funnel partners because they already do the due diligence for you. Or invasive species hitchhike. They hitchhike on horticulture plants. Typically, it's a koki egg that's in the plant itself that hatches once it gets to your house. That's typically how they get in. Mongoose, sometimes stowaway on our shipping containers. Sometimes people even just bring plants just for fun, for cuttings. And then our biggest issue right now is coconut rhinoceros beetle coming in its breeding material, which are compost bags. Oahu has had a big problem with that, where people will go to a big box store, they'll buy a bag of compost, they'll see giant boreholes in it, and it's infested with coconut rhinoceros beetle. See next. So there's different threat levels for invasion in Hawaii. So there's statewide. An example of a statewide one would be a threat of snakes. So snakes are a 911 call because we don't have any snakes. So this is a brown tree snake from Guam. We actually had some of our team sent to Guam to know how to handle them. So far, we don't have any on breeding in Hawaii, so it is a 911 call. An island-wide one would be an island-specific species, would be like little fire ant. We do have little fire ant established in very isolated populations right now, but unfortunately, since 2021, I have seen more populations pop up. And then intra-island, meaning from different areas of the island. So Myconia would be one of them. Myconia is isolated in Wailua, and we want to keep it that way. And then the invasion curve. I love this diagram because it's a good way to explain to the general public why KISC can't control every single invasive species you see. A lot of the time in my position, I get asked, why don't you control this and why don't you control that? It's because, one, there's 10 of us. There's one of me. But also, you know, the way that funding works is we are going to get funding for things that we can possibly eradicate or keep from coming here or from spreading. That is going to be the top priority or the top threat against multiple levels of our livelihood. So in this invasion curve, KISC operates within this area, which would be considered what is that word? Incipient. It's the end of the day. It's Pahana time. So incipient and invasive. So within this area would be incipient or invasive. Incipient meaning that it hasn't gotten here yet, or it has just got here and it hasn't become widespread. Invasive meaning that it's starting to spread. So in this area, that's where our core species and our priority species fall. So in this area, it's the first occurrence that happens, scattered locations, which is where little fire ant is for us. And then in the early detection program area, that's kind of where we work. And then once we get into the management area, that's where it starts to become really widespread and we need to partner with other organizations. And then finally, once we get into the restoration area, I know it's a little misleading because it says restoration, but really it's to the point where it's beyond our control. The scientific word is naturalized, and it's misleading as well. So naturalized meaning that it is far gone. It is out of our hands, and then it becomes a personal, if you are a private landowner, if you have albizia, then that becomes, unfortunately, your burden. We can recommend partners, and we can recommend ways on how to keep invasive species from coming to your property, but it is beyond our funding and our ability at that point. So what are some of our priority species? Here is a more detailed photo of Myconia. As you can see, it has this purple underside of the leaf, and that is a key indicator of it. It also has 3 long barbs through it. So like I said, it grows up to 50 feet tall. It has leaves up to 3 feet long and 1 foot wide. When naturalized forms, it forms a dense monoculture, so nothing else can grow underneath it. So I'm showing this boot because, like I said, it is a prolific seeder. It produces up to 20 million seeds per plant. A lot of seeds, a lot of grains of sand that you could accidentally step in. And those seeds can be spread by birds, boots, hooves, vehicles, machinery. But luckily, the location that we have is not in a heavily trafficked area. So we've been lucky in that sense where it hasn't had a lot of people or things that we know of going through there. As far as animals, I can't tell you. Another one is the little fire ant. So since we're in Princeville, our original infestation was on the north shore of Kauai about 20 years ago. And since then, for everyone out in cyberspace, the sprinklers are really going out today. So our first detection was about 20 years ago on a private property on the North Shore. We didn't have a detection until about 2021. when it popped up and there had been a growing population on a somewhat abandoned piece of property, meaning nobody had been on that property in about 10 years. The thing about little fire ant is they move about 5 feet every year. So for the radius that it had been able to reach, it had been there for a long time. To give you a personal experience, when we did our surveys with our team, it was so heavily infested that it was like raining fire, that our guys needed to wear hazmat suits because it was so bad. So it is one of the world's 100 worst invasive species. In places in Tahiti, on certain islands, people have completely abandoned their ancestral homes. It is so bad to the point where people won't come out on a windy day. Here in Princeville, I'm looking outside and there is a lot of wind, and I can easily tell you if we had little fire ants to the bad point that Tahiti has, we would not be able to walk outside today. This will, if left unchecked, change how we're able to interact with our home. We won't be able to go to the beach. We won't be able to go for a hike. We won't be able to walk our pets in the afternoon. So here's a photo if you want to zoom into. They're 1/16 of an inch, meaning they're the width of a penny. They're incredibly small. And most of the time we get called for tropical fire ant. We have 2 types of fire ants on Kauai, the little fire ant and the tropical fire ant. The tropical fire ant does sting, but it's not nearly as bad as the little fire ant. The little fire ant stings are so bad that they can actually cause cornea clouding in pets' eyes because they like the food in the food bowl. The pets go to eat the food, it climbs on their face, and then they can be blinded. Yes, they're incredibly small, much smaller than a normal ant. An ant smaller than an ant. So another thing that I like to point out is that they typically are moved, nests and satellite colonies are moved in leaf litter, in small cavities. An entire satellite colony can fit in the size of a macadamia nut shell. That's all you need. That's all you need. And they like to form things called super colonies. So what will happen is if you have a small colony in one side of your property and there's another one kind of adjacent to it, they'll keep creating smaller colonies until it becomes a super colony, and it'll have multiple queens. So it's not like you put some andro out and then they're gone. It's an entire process. So even 20 years later from our original infestation, we go back to that same place just to survey to make sure they haven't come back. Once you have it, Once you have it, we have to keep coming back to check it because the chances of it starting up again are very high. Let's see. So a trans species, LFA are highly skilled hitchhikers. They can hitchhike on your shoes, on your clothes. It's kind of my biggest fear to ever go to Big Island, accidentally go hiking and then bring it back on my clothes. So anytime I do go hiking out there, I shake out everything. I make sure everything is washed or is vacuum sealed and goes straight into the washer when I get home. They're carried on plants, cargo, vehicles, and they form super colonies. Yeah. So here is supposed to be a video, but technical difficulties. So here's just a photo of some of the commonly found ants in Hawaii. So here's a long-legged ant. You can kind of have the ruler for scale. We have the tropical fire ant here. And the main thing is about the color. I want you to note the color is a dark reddish brown. That's the one that we have at most of our beach parks. Here is the crazy ant, the black crazy ant. And the little fire ant has more of an orange color, and it's much smaller. Another characteristic is that they move very slowly. If this video was playing, you'd see these scuttling around like a normal ant would, but these ones move incredibly slow. The next one is coqui frogs. So we did have a population of coqui frogs for about 10 years in Lawai Valley, and KISC got rid of it. So success story. Occasionally they do come in, but we don't have a breeding population right now that's widespread like the one in Lawai. For the audience, they're asking if there's a new one in Kekaha. So far, we haven't had any reports from Kekaha. But if you are out there and you hear it, nope, not in Kekaha. We haven't had any calls for Kekaha. But if you're out there and you hear it, give us a call. So coqui frogs. Oh, that's right. I had a audio playing for this, but it's not playing. Oh, well. Oh. Hopefully the audience can hear it online. So that is the call that you'll hear. It has that distinct koki. It's a two-tone call. They are loved and native to Puerto Rico. Love it in Puerto Rico, but they just don't belong here. So the koki frog has, of course, if you've been to Hilo and any time in the last 20 years, so you'll hear it. I do know that it had become a big problem for Hilo, that a lot of people refused to visit there, and it was a big drop in their tourism. We don't want that here. Let's see. So they're a small frog. They're up to 2 inches. They have a nocturnal call, and they're voracious feeders on insects. So they love insects. Here is a photo of some of our lookalikes. We do often get called for the greenhouse frog. If you have a frog that you think might be a koki frog, typically it's a greenhouse frog. You can tell based on the coloring and the size, and also the toe pads. If you look at the toe pads, they have very distinct flat toe pads for the koki, as well as like a line that goes down, and they're all kind of one color. But if you have one, best to just capture it in a bottle and call us. The best way you could do that is actually throw them in the freezer, because it keeps them from chirping or sneaking, stinking up your house. But it also kind of just freezes them in time for us to be able to analyze later. And the unfortunate star of the show is coconut rhinoceros beetle. So can I have a show of hands, even online? How many of you have heard of the coconut rhinoceros beetle? Very good, very good. So that means I'm doing my job, right? So the coconut rhinoceros beetle had been present on Oahu for about 10 years prior to it getting here last year. It got here in about May of last year, where we discovered a breeding population on the east side of Kauai. Since then, we have had a few singular detections across the island, ranging from Hanalei to about Lihue, Puhi area. Luckily, we haven't found any on the west side, so that's a plus. And the biggest issue we have here is it's, from what I hear, non-discriminate on what it's going to eat. It's not only coconuts, beyond coconuts being the tree of life and coconuts being an incredible cultural resource and a food resource for a lot of us. They've also now been showing to go after things like sugarcane and particular varieties of banana, as well as eggplants, things that grow in your yard. I have a lot of close friends in Waianae, which is the west side of Oahu. From when I left college in 2018 till now, there are no more coconut trees that are healthy beyond, in Waianae. I do remember going up to Ka'ala Farms back in like 2017, and I was introduced to Uncle Eric Enos, who had one of the first detections up in the back of that valley, and it was just a clear die-off of tree. Here on Kauai, we have so many historical palms that were planted by our ali'i, especially on the east side. Those are part of our history. Not only are they a threat to coconut trees and all of our agriculture, but also our lolu, our native lolu, are a huge risk. Especially being on Kauai, we have endemic species of lolu from Ni'ihau as well as from Hawaii. We're the last place to have it. I have been told by the coconut beetle response team, that they actually kill lolu faster than coconut trees because they think it's yummy and delicious. Want it. So coconut rhinoceros beetles are about 2 inches. Another lookalike is the oriental flower beetle, which is smaller. So at some point during the instar phases of the larva growing, they can be around the same size, so maybe about 1 inch. But if it is a coconut rhinoceros beetle, it'll definitely grow to 2 inches. If you see a beetle or a larva that is for sure 2 inches, it is 100% coconut rhinoceros beetle. There's nothing bigger than that. At any point, if you're searching through your mulch or your yard and you find grubs, I would say just put it in a bottle and call us, because only by being able to identify it and kind of see how it moves and look at other physical characteristics, we're going to be able to identify if it's coconut rhinoceros beetle or not. Yes, alive, because they They do this thing where if they're put on their backs, a oriental flower beetle will flip over and start going back to crawling, versus a coconut rhinoceros beetle will form like a C. So it'll scrunch up and it'll form like a C, and then it'll eventually turn over. Yeah. Here's a photo, the large photo of it. They, after seeing them up close and like being able to hold them with gloves, if you catch them, I would say wear gloves, because they do carry dysentery. So wear gloves and wash your hands really well if you find them. They have very distinct hairs on them, as well as these little arms that are kind of like, you know, they move. I'm sorry, this is the end of the day, so I hope I'm just entertaining at this point. So the coconut rhinoceros beetle larva reaches about 3.5 to 4 inches at any given time, especially at the largest part before it becomes a pupa. It hatches from eggs and lives in the green waste, mulch, and compost, as well as rotting plant material. So all of those are considered breeding populations. As much as we care about getting the live adult beetles, our biggest threat would be managing the breeding population and the breeding material, because you can get rid of all the adult beetles you want, but if you have a giant mulch pile on your property and you're not doing anything about that, you're going to keep getting beetles. And not only you're going to get beetles, but most likely your neighbor will get beetles, and it'll keep spreading. I explain this to the students. It's like COVID. If you have it at your house, you already are a threat to your neighbors. You don't want that. And I take it super seriously. So one of the telltale signs is these V-shaped cuts. If you also want to get more information on this, you could go to our website or the Coconut Rhinoceros Beetle Response Team website. It has these cuts here. And the way that it does that is the coconut rhinoceros beetle adults like to attack the spear, which is the fresh new fronds that are coming up at the center of the tree. So one of the ways that we mitigate that is we could use netting to catch them before they get in there. So you actually have to check the tree every single day to see if any got stuck in there. But what it is when the spear is growing like this, they burrow in that way, and it creates those snowflake effect kind of. But typically, when you have signs like this on your tree, it's already about 3 to 6 months of infestation. By then, it's probably through your tree and in your mulch pile or green waste pile. Another sign are these giant boreholes, which are always huge, like 2 inches. And then for palms, fan palms, it creates a scallop cut as well. It's the same thing if you were to do a snowflake and you cut a hole right through the whole snowflake accordion and then you open it up, that's what happens. It is also known to attack hala. So it is a huge threat to our weaver community. From what I've been told from people in Waianae and people who have experience with it, it doesn't typically go for it, but say there's a coconut tree and a hala tree, it's gonna go to it. If it's neighbors, it's gonna go to it. Here's some more photos of damage at the spear. Another thing that they'll attack is sugarcane and lolu and other palm species. So if you have any palms, it's a big threat. Hello? So how do we stop the spread? Right now we do have a community trapping program. We have those big lantern traps, those black lantern traps. And we are having them being placed in very strategic areas. So because they are a pheromone trap, we're not recommending people have it everywhere, like 50 feet next to each other, and because by doing that, it creates kind of a ladder for them to follow to the next place they're going to be having their breeding population next. So right now we're being very strategic with our placement of these traps. Just gonna go right out there and say that we have had people say that it's gonna attract beetles to your property. And just to get rid of that rumor, it doesn't do that. It is technically a not very effective trap. It is 10 to 12% efficacy. So really it's an early monitoring trap. If you don't have it on your property and you have a large property with a lot of possible breeding material, it's good to have one, but not hanging on a tree, like a coconut tree, but close to the breeding material, because the chances of you catching the beetle through the trap will be a lot faster than waiting for the damage on the tree. Like I said, those V cuts happen at a 3 to 6 month infestation already. But if you have a trap, the chances of you catching one and getting it early are much higher than if you were to just let it do its thing. It does not kill, so it's just a monitoring trap. And yes, you have to look. So part of the community trapping program is an agreement between the property owner and us that they will check their trap on a weekly or even like week and a half basis. And we have an entire system for that, so that we're able to catch it early. Another way that you can get rid of it is, or not get rid of it, but prevent it from getting to your property, is minimizing the amount of breeding material you have. So that includes green waste, mulch, coconut fronds, green waste piles, anything that is piled up and green material and warm and wet. So leaving material whole is always recommended because it doesn't create those pockets for it to kind of grow and proliferate. CRB prefer moist, small particle size and active decomposition like palm materials. Or you could also take those mulch piles and spread it thin periodically to about 2 to 4 inches to let it dry out. I know it kind of defeats the purpose of mulch, but that's the best way we can do it. And then visually surveying it. The eggs are the size of a Tic Tac. So really, until they start becoming larvae, it's going to be impossible to find them in a pile. It's like looking for a needle in a mulch stack. So no stockpiling, reduce stockpiling on the property, or restrict transport. So not taking in green waste from other properties, not taking your green waste and moving it somewhere else. And then also, let's see. So disposing at state certified composting facilities. One of those is Kauaʻi Nursery and Landscaping, Green Earth Matters, Heart and Soul Organics, or don't use mulch and compost, which is hard because we are in agriculture community. We're a sharing community. It's what we do, it's how we live. But just trying to be aware of the threat that could possibly spread and what you could possibly bring onto your property. That's a huge thing. It's just being aware. And then finding alternatives, maybe weed mat or ground or rubber fertilizer, things like that, as much as we don't want to do that. Cardboard could do it. Yeah. So the question was if cardboard would be a good option, and I think yes, because if you're actively just taking your cardboard and putting it straight onto your garden, but still, if you have a garden, it's always good to kind of like sift through to see if they might be going in there because they love soil as well. The thing about coconut rhinoceros beetle, as I've been told, is if they're in a large mulch pile or compost pile, if you start taking it away and airing it out, they'll actually burrow into the ground until it gets warm again, and then they'll come right back up like zombies. They're incredibly resilient. That's the thing about our invasive species here. They're incredibly resilient, and it's a headache for me. Southeast Asia, they are heavily infested in places like Guam. So we were asked where they come from. Right now, I'm actually in conversation with some professionals on Oahu that have a Pacifica-wide coalition of professionals who have been studying this for up to 20 to 25 years already on top of Oahu. So these are international. It's people from Micronesia, from Palau, from Guam, who all have lived experience and have tried different methods of how to control it. So now we're starting conversations with that coalition, which I hope will bring us more solutions for the future. And I'm very optimistic about it. Yes.
If I had strawberry guava trees in my yard.
So I think the question back to you would be, is it bordering your property or is it an isolated kind of situation? I mean, if you have them, I definitely recommend not having them because, you know, birds could take the seeds and spread it somewhere. But I do know that some people love to have it for jams or, you know, walking sticks, or it's part of their craft. So I completely understand that. I think what I like to get across is we don't want strawberry guava up in our forests and up in our natural areas. I don't want to say like I recommend it, but if it's in a controlled space, I guess. But if it's bordering your property, I'd say get rid of it. Any other question? Yes.
Composting, does that not apply to home?
It does apply to home compost. It does. So she asked if home composting, if the CRB recommendations for home composting, it applies to that. And yes, it does. Any kind of breeding material, if coconut rhinoceros beetles at your neighbor's house and it flies over, it's going to want it. So just doing your own in the best in what you can is spreading it thin, checking it, sifting it. That's the best way to keep it without having to treat it chemically or with heat. Or if you are doing composting, make sure it's hot composting and then keeping it in a sealed container. So these coconut rhinoceros beetles, if you put them in a thin water bottle, they can burrow through that. They take their little elbows and they burrow right through anything with ridges that they can kind of get a grip on. Even sometimes the cups that we have that are attached to the black lantern, if the hole was big enough, they could actually burrow through that and get out. So anytime you do catch a CRB, put it in something like a glass jar or something without ridges or something with really thick plastic. Yeah. I haven't actually looked into that because I haven't done it myself, but the ones that my dad has at his house, I don't think it gets to the temperature that it needs to be. Yeah, because it has that really good ventilation. So I don't think it does get to 120, 125 degrees, which it needs to be. But even if you do have that, it has holes and it has, access to the soil underneath. So it's still open for infestation that way. So it needs to be in a sealed container if you're going to do that. Yeah.
So hot composting is okay.
Yes, hot composting, and you got to check the temperature to make sure that it gets to that temperature. It's hard to do. I know. Trust me. Mhm. Oh, thank you. Any more questions? Okay.
If it's freezing, so say I do go to Milo and I go hike, or I go to go hiking. Freezing stuff.
I would say yes because, or no, not Rapidohelia.
Oh,
Oh, okay, perfect. So for the audience, she's asking if freezing your clothes or shoes would be able to get rid of Rapidohelia death after traveling to places like Big Island. Kim, would you like to answer? Would you like to? Okay. And Kim says, oh, so high heat.
Or some solarization. In place of the sun, it's gonna bake it.
Yeah, so high heat, not freezing for the fungus. Ants, if you freeze them, they typically die. So yeah, I would say yeah for the ants. Mhm. Oh, thank you. Thank you. Yes, if you're at the Honolulu airport at any time, I do believe it's on kind of the further end of the check-in, but there's biosecurity and Interactive's biosecurity display for all of the ISCs in Hawaii. So check it out. Yes. The parakeet. Okay. So here we are. Here is my mo'olelo for you. So the story of the parakeets are that they came from a single pair, very much an Adam and Eve moment for them. They were released in, assuming the 80s, that's what we have from our research, is probably around the 80s, and then they were multiplying very slowly until about the early 2000s, and it skyrocketed. So maybe not right now, but we are actually going after funding for a pilot program through the legislature so that we can apply the research that we did 2 years ago. So we did a 2-year study with Texas A&M University where a researcher actually came to Kauaʻi. We, did research on what the birds were eating, how they were roosting, how they were migrating, where they were nesting. And the beautiful thing about our rose-ring parakeets is they're very special compared to every single one around the world. See, so we have, we tried experimenting with like a birth control kind of thing through feeders. internationally, everywhere else in the world, they love the feeders. You put peanuts in the feeder, they go to the feeder. It works. Not here. We didn't get one parrot. We didn't get one parrot to come to any feeder during the whole 2-year study. So it's just, there's so many good things to eat. Why are they gonna go for peanuts in a feeder? So that's kind of where we went with our study. But the conclusion of that study is that if we're able to get get rid of half of the population every 7 years, for 7 years, we're going to be able to get it into a controllable population. So now it's just getting funding for it. So if you're watching, or if you see us call for testimony for support, that is how you can actively help us. Because when we go for funding for projects like this, we need the community support to say that they want this funded. So we're going for that right now. That's the latest with the rose-ring parakeet.
What's the outcome of the information that anyone is getting science where we're meant to be reporting any occurrence?
Oh, so yeah. So that was primarily for the study itself. Since then, our funding ran out for that project. But I'm sure once we get funding for this pilot program, it will restart again.
There's
Yes.
still a hotline and like, just to know
Yes.
where they are.
Yeah, it's kind of to,
They're tracking.
yeah,
Yeah, but like, it's like.
yeah, we're not
So
actively
15
controlling.
means-
Yes. Yes. Another interesting thing is that these parakeets roost and they're separate from their nesting. So twice a year, the females and juveniles will leave to a mysterious nursing area or a nursery area, and we are still trying to figure out where they go. Maybe they pick a different spot every year. Maybe they pick a different spot every season. Yeah, so they have a main roost, like if you were to go to Kauaʻi or go down to Poipu, where it's just they're flocking. And that's their main roost, but during their mating season, the females will separate. So it's like a distraction. They're like, all the males are here, look at us over here. And then while the females are able to go and have their babies. Very interesting. Very interesting. What's crazy though, is that they also like to create mini roosts. So they don't go to the same roost. They'll go to like a mini one here, some will go here, and they never go to the same one. They're incredibly smart, incredibly smart. In some ways, you got to give them credit.
Nothing's going after them.
Yeah. Oh, they're living their best lives for sure. It is not right now. So it's actually, yeah. I do believe it's closed. The part for testimony for this particular pilot project is closed. I can check and follow up with you if you want to send me an email. Yes, so that's kind of where we're at right now. But we're in the process of it. And what's crazy from our data, we learned that they eat all over the island. So they could sleep in Lihue and eat in Keikaha and come back. Yeah. Yeah. Yes. We're working on it. There's like 7 of us, and then there's like 3 of us to do the job. Yeah, so HGOA, we only have 1 agent on Kauaʻi right now. All of our agencies are incredibly understaffed at any given time. So if you're looking for a job, come join us. Come join conservation. Yeah. Yeah. Okay, so if there's any other questions, okay. Thank you. Did I stop? Stop sharing. And then leave? Okay.